Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 33, we will talk about sanitary landfill design, and this is part 1 of this lecture. The concepts that we will cover are on different kinds of landfill construction, then sanitary landfill operational alternatives, sanitary landfill typical section, liners, drainage layer and covers. So, as we have learnt earlier that every ULB need to make sure that they have a operational landfill site and a properly designed and engineered facility. That's why we call them sanitary landfills. And there are several laws and regulation in this regard. What kind of waste should go to the landfill? What should be the design of the landfill, and so on. So, some of this we have discussed earlier. Then we have talked about the landfill siting criteria. That means how and where we should locate landfills, how should we select a particular location. And then in this particular lecture, we will start talking about landfill design. Now, landfill design and landfill area calculation are done together. Why? Because for different kinds of design will result in different kind of area calculation. And also landfill construction, landfill operation, and eventually landfill closure. That is how we complete the operation of landfills. This all needs to be discussed simultaneously when we discuss the landfill design. So overall, the next 3 lectures will cover all these different components of landfill design, as well as certain aspects of its operation and the closure procedure in the next subsequent lectures. So, when we talk about landfill design, these are some of the aspects that we need to cover. So, one is the geohydrologic and geotechnical assessment. So, that means even before we start the design, we have to conduct this kind of assessments. So, last time when we were talking about landfill siting criteria, we have discussed about this kind of data collection, this kind of inspection that needs to be taken up, and these are the things that needs to be inspected. Then waste stream categorization, that is to understand exactly what kind of waste is coming to the landfill. Now, even though we are only supposed to take waste which are non-biodegradable and also non-recyclable waste, particularly inert waste, to the landfills, but as per different ULBs, as per at what stage the ULB is currently in terms of solid waste management, different kinds of waste reaches the landfill, and sometimes we still receive mixed waste in the landfill, which means that there is still organic waste mixed with other waste that comes to the landfill. So, first we need to understand what sort of waste comes to the landfill. Then, what are the operational alternatives? What sort of designs we could think of for the landfill? And within this, according to that, there will be designs for different liner systems, drainage layer, cover. What are these? We will discuss this in detail. But as you understand, liners prevents the flow of leachate into the groundwater. Drainage layer is one where we store the leachate so that it can be collected, and covers are barriers which prevents water to get inside the landfill in the first place. Right. So, these are the different things that we will discuss. Then we will talk about leachate management, landfill gas management, surface water management, groundwater management, water balance analysis. This will be taken up in the next lecture. So, first, we will start talking about the sanitary landfill construction basis. As you can see in this particular image, we have a landfill, and at the bottom we have the landfill liner. So, this is the landfill liner. Liner is the one that layer which prevents water to flow down, the leachate to move below the landfill. That is, it prevents the landfill, the leachate to mix with the groundwater. And as you can see above the liner, and as above liner, drainage layer, and all these things that we will discuss in detail later, you see that when there is something called a cell, and then each cell there is not only one cell, there are multiple cells, right? So each of these layers of cell that you can see, first cell, second cell, there could be further cells over here as well. So this is the first layer of cells. So once the first layer is complete, then we move on to the next layer and the layer above it. In gradually we go upwards, right? So each of this is known as a lift. So there are cells and then there are lifts. Now why we need to do it in this way? Because every time when we put garbage inside a particular area or inside this landfill, we have to do it in layers. And once this layer is finished, then we move on to the upper layer. Now the height of each layer is also the height of the cell. Now how do I determine that? The cell's height is determined primarily based on two factors. One is based on the amount of garbage that comes to the landfill site every day, and also based on the physical, the kind of equipment and kind of the process that we adopt to store this garbage or push this garbage into this particular landfill. So based on the the kind of equipment that we use, the height of the cell could be only as per the height of the equipment, because we use mechanical equipment to lift the garbage and put it at a particular location. So that means if I am using a bulldozer like this over here to push the garbage inside, so based on the height of the bulldozer's this face, it will determine the height of the landfill. Similarly, if I have a sort of bucket loader, which is like this kind of a system which lifts the garbage and places it, in that case also we will see that based on the height till which this arm can move, based on that we will determine the height of the cell. So there are typical heights of cell that is possible, and once this layer is finished, one cell at a time, we will finish this, then we will move on to the top. And what it helps is, because we are moving on the top, the vehicle has to move above this particular layer, and automatically because of the weight of the vehicle, the garbage will become further compacted. And to facilitate movements above, sometimes we have to give this kind of benches, so that which allows vehicles to continuously move, and it allows the vehicle to gradually move to the top, because we allow these surfaces where the vehicle can rest, and the rest of the surface we will give a slope, so that water can actually flow downwards, right? So this slope is given so that vehicles can climb along up this slope, and also this slope allows water to come down from the top as well. So, and this benches helps for two purposes. One is it breaks the flow of water, and we will use design surface water drains over here, so that it will collect the water coming down along the slope, capture it, because if I allow the water to travel for a longer distance, then it will gather speed and it will result in erosion. So instead we break it at the different benches, and so it slows it down. At the same point of time, these benches could be used by vehicles to move as well. So that is how we gradually build up a landfill. So these are known as cells, and these are known as, in each layer of cell is known as a lift, right? So landfill is constructed using a series of cells and lifts, and cell height is as per the required to adequately dispose the daily refuse volume, and maximum height is around 6 to 15 feet based on the kind of equipment that we are using and so on. But primarily the size of cell is based on the amount of garbage that comes in. Now why it is important? Because every day the garbage that comes into the landfill site, that needs to be compacted, pushed, and then placed at a particular position in the landfill. And once we do that, we also cover that garbage with a layer of soil, so that water, at least some amount of barrier is there, so that the garbage cannot litter, or because of wind it may not spread. At the same point of time, it is protected, and there is smell and other things that comes out of garbage. So if you give a layer of soil, it is protected from that, and primarily we prevent water to get inside the garbage, right? So that's why we give a little bit of soil. And so our target is to minimize the active area exposed to precipitation, right? So that means the layer of soil prevents water to get inside. So cover material volume, that means we require some soil to cover this particular garbage. It should be at least 10 centimeter thick, and we need to also determine what amount of soil is required. That means not only the quantity of garbage is important, also because the landfill is not only the garbage, it's also all these different layers that we construct, liners, covers and all, and also the kind of soil we use for cover, right? So it's 10 centimeter thick cover, and it is given at every layer when one cell is done. So you can understand there is a considerable volume of soil that is required. And based on this volume of soil which is available on site, or we have to transport it from somewhere else, we can even think that how much, what sort of waste can be, stored in this particular landfill. If I have to import soil from further away, maybe it would not be possible for me to, the cost would be exorbitant. So maybe the life of the landfill would be less, right? So it is based on this amount of soil which is available on site, right? And if we import soil, then automatically the cost increases. So at one point, the entire operation may become infeasible, right? So 15 to so total around 15 to 30% of the compacted refuse volume, that is almost 15 to 30% of the garbage volume is the volume of soil. So that's a huge amount, right? And overall cover material volume in landfill is around 10%. So that means because soil is in some, like at the end of each cell, it is only 10 centimeter, but in the liners, it's a little bit more. So overall, we say that around, even though at one cell level, the value is less, at around 15 is a little bit more, 15 to 30%, but overall in the landfill, you see that around 10% of the overall size volume of the landfill is for this kind of cover materials. Now, the shape of the cell, it again depends what should be the size of the cell. The height is more or less 6 to 15 feet. So, roughly in standard operation, we can take around 2 meters because that's right, the human height, and more or less the equipment can raise the garbage and then compact it to a height of 6 meter. You can also see till 6 meter. Beyond that, it's difficult to see. So more or less, even though we are saying 6 to 15 feet, so roughly 2 meters it's standard size that we use sometimes. And more or less the shape of the cell is we try to keep it squarish. Now, why square? Now, if it is square, then what happens? It's same on all sides. And more or less it's easy to estimate that, okay, how to cover it with soil and all these things. So we keep a certain profile, right? And the sides of the cell are also sloped at 3:1. Why? Because this allows us, for like if you see that this cell is sloped as 3:1, which allows vehicle to pass above it, and if not, the next cell may come also in the same slope way and so on. And because slope is required even for when the equipment is used to, fill up this cell and all with garbage, then also it does it in, it is difficult to, fill it up like at a straight line, right? So it will fill it up, giving it a slope, right? So overall, a slope is given, and the slope of the side slopes are around 3:1, and you can see that the similar slope profile is maintained for the overall landfill, this profile as well, or for this particular landfill, the entire section would also have similar 3:1 slope as well. So then, talking about landfill volume, 1 ton of waste that comes into the landfill, that roughly becomes around 1 cubic meter of sanitary landfill volume. That it fills around 1 cubic meter of the typical sanitary landfill volume. Now, why 1 cubic meter? Because earlier we said the density of waste is around 0.85 cubic meter per meter cube, 8.85. The density of waste is something around 0.85. So that means that 1 cubic meter of waste will hold around 850 kilograms of waste, right? 850 tons per meter cube. So that means this is the initial compacted density of waste. And as you can see, that is during the initial years, it's something around 0.8 tons per meter cube. But in subsequent years, because of compaction, because of vehicles moving on top of it, it becomes around 1.2 tons per meter cube. So it is, during the final stages. So roughly we can say during the average period, or during the middle years of the landfill, the volume required is something around 1 cubic meter for every ton of waste. So that's the rough density of the landfill site. So next, coming to how we should organize our landfill. So we will talk about the different operational alternatives for the landfill. So the first method is called a area fill method. As you can see in this particular image, we have a large working face. This is the working face of the landfill site. Vehicles can come directly over here and unload the garbage, and then machines like this, like a bulldozer and all, can push the garbage into this particular face. Now, what should be the size of the face? It is as per the size of the cell, right? So it could be, like as we discussed, like it's a squarish cell, but over here you can see it's a rectangular face sort of, right? So, or if this face is like this much, so maybe the landfill cell size would be something like this eventually. So that may be possible, right? Like this. Now, the size of the face should be wide enough to accommodate incoming vehicle stream. So that means every hour garbage vehicles are coming and it is unloading garbage. So at least in 1 hour there are maybe 2 or 3 vehicles coming. At least that area should be adequate for 2 to 3 vehicles. It depends on how many vehicles are coming. So at least there should be around 15 meters. So roughly it is 15 meters, but it could be even less. Even though it's at least 15 meters, but sometimes we can even go a little bit lesser. But we will try to stick to this particular value because it allows a few vehicles to come and stand and then dump garbage. Now, sometimes what happens, these vehicles are not allowed at this particular phase because of many reasons. Because the tire and all these things for these vehicles doesn't allow them to move inside the landfill site, right? So in that case, these vehicles will dump the waste at this particular layer, and then compactor vehicles can compact it and finally push this vehicle or lift this garbage in some sort of loading bucket loaders, and then carry it down the landfill site and then push it into the cell face and then make the next cell. So in this way it can happen. So this is the active fill layer that is going on, and this part is already completed, right? So this is fully covered. So we are using this area to freshly unload waste in pre-compact and then pre-compacted by dozer or compactor before moving into the active landfill area. So both can happen. That means we are not allowing vehicles to come to this area because of the nature of the soil, or vehicles may get stuck. So instead they load it, they bring it down to this level, and then we use this kind of bulldozers and bucket loaders to take it down and then push it into the phase where we are actually filling up the garbage. So refuse is then compacted and pushed to the working face layers of lifts of 50 centimeter in thickness, and slope given is 1:3. So every lift is around 50 centimeter, means one layer of lift. Now multiple of this actually makes the total layer of the lift, which will come down to around 6 to 15 feet, right? So at every time a garbage is taken, approximately 50 centimeter of height, it gradually builds up on 50 centimeter height, and finally it reaches a 6 to 15 feet. And once and we compact that particular layer, and finally that's the end of that particular day's operation, and we cover and give a cover on this particular amount of garbage. And so this cover that is given, that is once the cell is finished, we complete putting garbage over here, and then we will put cover over here, right? So this cover material can come from adjacent land. That means soil is excavated from the adjacent area and then we can use it. Imported from borrow pit areas, we can do pits in some other areas and we can import it from other areas as well. And also it could be from previously constructed stockpiles. So this is where we can get our cover material. But look, what we have discussed earlier, that at the end of the day, the more material available at site will lessen the cost of the overall landfill. Then comes the trench fill method, and as you can understand, in this method, it's a little bit different, where we first create a trench, or that is a hole in the ground. So that means we first create a trench like this. We dig it up, and we may store the material over here, or may store the material over a little bit further away, and then we start putting garbage inside this particular trench. And once this is filled, before it even gets filled, we will construct another trench beside it, and again we will start putting garbage over here. And by that time, when we start putting garbage here, this will be covered, this will be filled, and this particular site is completed, right? So in this way, we move from one trench to another, and eventually the entire area is covered. So waste is sprayed and compacted in an excavated trench, like as you can see in this image. This waste carrying vehicle is bringing the waste over here, and we are using a compactor to compact this particular waste. Trench is excavated in phases as per design depth, and soils are stockpiled. So once we excavate, we can stockpile the soil and we can use it as cover, right? And then waste is placed on one end of the trench and compacted till the desired height, and this height is something around 8 to 12 feet. So this is, you can say that it's similar to a lift, right? So usually the trench, it depends on the trench depth. Now trench depth again depends on what type of soil, where is the groundwater layer, groundwater table, and what sort of excavation equipment that we use. So it could be something around 20 feet or even sometimes beyond, right? But each cell is something around 8 to 12 feet. So as you can understand, over here we can fit roughly 2 cells. So roughly 2 lifts over here, one cell above another. And then trench width is something around 100 feet or less. This particular width, that is less than 100 feet. And once a trench is filled, the next adjacent area is excavated. And as you can understand, this is a method where we are creating a hole in the ground, and automatically it allows better control of litter than the area fill method. So in area fill method, when wind comes, a lot of pollution happens, dust and litter, garbage can spread over an area, whereas in this particular case, it's a bit more protected. But as you understand, this also has got some negatives associated to it. If there is a rainfall, then there may be chances of water logging and all. So that's a big problem. So usually we don't find it in our country. And in our country, we usually go for something called a modified area fill, where it's a mix of both the area fill and the trench fill method. So that means usually in areas with low groundwater table, we go for this kind of modified area fill. It starts as a trench landfill. That means we first create a hole in the ground, and then once this is filled, we start going up, right? So then we will go to the top. So it has got a similar working phase as the area fill method. So eventually it becomes like a area fill method, and excavated material stockpiled for use as daily cover. So this allows excavation of some amount of material which could be used as cover. So actually the amount of material that we use that will require as cover can be excavated, and that could determine the depth of this excavation as well. So this is roughly the section of a typical landfill. So you can see different components to it. For example, as you can see, this is sort of an area fill method, but you can also call it a modified fill, because obviously there is some excavation has been carried on over here. So this is a drain given at this particular edge, and these are those benches that we talked about, right? And these are the lifts. You can see in each lift, the landfill has gone up. And this surface, this stormwater drain is given so that water is captured coming down the slope, and also it prevents water from the surroundings to come inside, and it gets trapped in this drain, and the drain is diverted to somewhere else, right? Then at the bottom, you can see this bottom liner. So this is, the mineral liner or the soil liner. Above it, we can have certain other layers, a secondary liner. Then you can have this geosynthetic clay liners. We will discuss about this later. So these are systems which prevents, leachate to go downwards, because leachate is generated and it starts moving downwards. So this is where this is a drainage layer over here. So this is where the leachate drainage layer is made of gravels and all. So leachate comes and gets stored over here, and it cannot go below because of this liners that are prevented. So the leachate will start accumulating over in this drainage layer, and it will gradually go up. It then fills up these perforated pipes which are laid, which collects the leachate, and it takes it away into some sumps. Maybe there is a sump over here, and from here we can pump the leachate out. Or similarly, from the layers also, we can also the pipes could be also connected directly to some sump from where it could be pumped out, or it could be some amount of leakage can happen and we can even have another layer to collect leachate from that layer and also pump it out. So anyway, so the leachate, it's pumped out from this particular layer, is brought over here. It is this is a pump house, then it is brought to this leachate storage tank. It could be again treated inside the site, or it could be treated or it could be transported somewhere else and treated there as well, right? So from over here, some amount of leachate could be recirculated back. As you can see, this is where the recirculated leachate is taken. From here, the leachate is again allowed to pass through. Now, why it is done? Because in arid areas and all, the moisture is less, and we want moisture to be a little bit more in the landfill so that it facilitates the degradation of organic matter and all. So sometimes the leachate is circulated. So that is what is being shown over here. In addition to that, we can see this sort of vertical pipes or sort of wells, you can say. These are filled with again gravel and other material with pipes inside. These pipes are for gas collection. So all the gas that is generated is moves into this particular these wells, gas collection wells, and from there we can actually pump the gas out. And this gas is also taken from using which we can burn the gas, or we can also use it to generate electricity as well. So this is more or less the typical section of the landfill. And at the top we also give a impermeable cap or a cover so that water doesn't get inside the landfill. Right? So infiltration cannot get inside the landfill. Even so, some amount definitely will get inside, but we will try to our best of our abilities not to allow water to get inside. Then we will discuss about the liner systems. As we discussed earlier, liners are designed to prevent the movement of potential harmful pollutants beyond the boundaries of the landfill. So that means it's a barrier layer which prevents movement of leachate outside the landfill site. And the idea is to collect the leachate within the landfill itself and then pump it outside and then take it for treatment or for transportation to a different treatment site. So the liner should be designed in such a way so that it has very, very low permeability. That means it's a layer of, you can say a liner is nothing but a layer of soil. But the soil layer should have very low permeability. So automatically when the native soil doesn't have that much amount of permeability, we should have something extra to make it more non-permeable. For example, we can mix some cementous materials to make it more solid so that we reduces its permeability. So we can use clay or we can use amended soil. Amended soil is soil mixed with some amount of cementous material like bentonite clay and so on, right? And you can see that the system is designed, it has got several layers. So one is the bottommost layer, which is the original soil of that particular place. And after that is the liner. Usually it's a 90 centimeter thick liner, and it includes 3 layers of clay or amended soil, and each layer is 30 centimeter thick, and the permeability is 1 into 10 to the power minus 7 centimeter per second. It should be less than 1 into 10 to the power minus 7 centimeter per second. So that's the permeability allowed for soil in this particular case. But if the native soil is not that, doesn't have, it's more permeable than this, in that case we may go for a geosynthetic clay liner, which is sometimes we use a geosynthetic clay liner, which is like a bentonite clay sandwich between some geotextiles. Geotextiles are fabric material which allows passage of the leachate. Now what it says is, why we do that, because sometimes what happens when we have two different layers of soil, one is very, very highly compacted and the other is allows, it's a sandy soil, allows passage of leachate, right? So how do I differentiate these two? So that means there has to be some form of barrier so that water can pass, but the soil materials will not mix with each other, right? So, or I have got the waste layer and then I have got the drainage layer, right? So waste and drainage should not mix. So there has to be something intermediate, right? So that is where sometimes we use this geosynthetic liners, right? So sometimes the geosynthetic liners along with some amended soil, that is using bentonite clay, we can create a layer which is like a sandwich layer in between, which can prevent movement of leachate. So along with that, we can reinforce this entire system. So either we go with soil, or amended soil or with geosynthetic liner and all. And along with that, we can also put a plastic layer as well, a sort of plastic, right? So HDPE liner is also utilized. So HDPE is high density polyethylene plastic layer, right? So this kind of, along with soil, we can use this plastic layer, which definitely prevents movement of leachate below. And this is a high density membrane, and standard thickness is 1.5 millimeter. And so this prevents water to go down in case the soil is not good enough, right? So liners some is required in most sanitary landfills, except in areas which are very, very dry, and with expert consultation we can avoid also putting certain liners. So as you can see over here, this is that HDPE liner which is being given, which is being laid on the top. So this kind of liners are laid at multiple, maybe at the top as well. So usually along with covers also, liners are given at the bottom. At the top also we can have some top liner, which is also known as, a cover system, right? So that means this kind of synthetic sheets are also utilized along with soil as well. So HDP liner, how do I decide on a liner, on a particular liner, right? So we have to understand some of its properties. So will it tear? Will it puncture? Will it resist, movement of, vegetation? That means some seeds and all are always there, and vegetation can start growing. So it should be creep resistance, adequate thickness, and so on. Then we have to also be careful about the overlapping of the liners. With of overlapping, welding, we have to weld these two layers together so that there is no movement through with these two layers, right? Then this should be as per the manufacturer recommendations. Then we should not be driving on this liners. That means once the liner is laid, we cannot drive on it directly. That means we cannot run the vehicles because it will tear the liner definitely. Every welding seam needs to be checked, and for stability, density, and thickness, so that there is no leakage, right? Now, the membrane selection, it could be HDPE, which is very common in the Indian context, but based on weathering resistance, soil compatibility, resistance to biological attack, physical suitability, compatibility with waste, we can select other liners as well. What are these? It could be butyl rubber, chlorinated polyethylene, ethylene propylene rubber, neoprene, polyethylene low or high density. In our case, we use high density. Polyvinyl chloride or PVC sheets, right? So all this could become liners in a landfill. So directly HDPE liner is not provided on the soil or below the waste, so it has to be protected using a geotextile or a layer of silty soil. So that means it's a buffer layer between the waste and the liner. Otherwise, because of the pressure of the waste, because of certain material in the waste, there may be a tear in the liner. So that's why we require a protection layer. Usually this layer is 20 to 30 centimeter thick. And the base liner is also known as the base sealing system. Similarly, the surface sealing at the top also we may sometimes use some liner as well. Geotextiles are given above the drainage layer. So we have the bottom liner, then we have the drainage layer, and then above that we are given some geotextiles, and then above that we have the waste. So we allow water to go through the geotextile, but we don't allow waste to mix with this particular burial layer. And then it allows the water to go inside the drainage layer finally, but the waste doesn't mix with the drainage layer, right? So that's the purpose of this silty soil or the geotextile layer. And once this is collected in the drainage layer, we can have our geosynthetic HDPE, our HDPE liner or some amended soil or clay below it, and so that it prevents the movement of leachate from this drainage layer further down. So that is how more or less the system is designed. So this is some specifications for the geotextile. Like if you use a geotextile, it should be 400 grams per meter square for bottom liner and 200 grams per meter square for top cover. And if landfill height is both height and depth is greater than 20 meters, geotextile should be at least 800 grams per meter square. Why more? Because of the extra weight of the waste that falls upon it. So it should be of sufficient thickness, and that is how thickness can be determined. Then leachate drainage layer is actually 30 centimeter thick minimum, and filter gravel with permeability greater than 10 to the power minus 2 centimeter per second is utilized to fill up this drainage layer. So above the liner we have the drainage layer. Now coming to the drainage layer, so as you can see these are the liners over here, and we have over here the drainage pipes are coming. This is where it is entering into the this particular drainage layer, and so we have got these pipes. The drainage layer also includes leachate collection pipes. So these are the leachate collection pipes that is collected in the drainage layer, right? It is directly above the geomembrane or geosynthetic liner or the 900 millimeter layer of compacted clay. So either it is the drainage layer is above the compacted soil of 1 meter 900 mm of compacted soil, or it is above the geosynthetic liner, whichever may be the design of the liner of that particular landfill. So a granular leachate collection layer, it is 300 mm thick as we discussed, and granular diameter is 25 to 50 mm, and design of the drainage layer is such so that hydraulic head of the leachate above the composite liner should be lesser than 0.3 meter. So that means above the liner, that means above the composite liner we have the drainage layer, right? And the drainage layer is something around 300 mm. So we should never allow more leachate to accumulate, which should go above this. Then what happens? Then it will mix with the waste and it will create a sort of saturated situation which will create other problems. So always the amount of accumulated this leachate should be less than 0.3 meter. Now this accumulated leachate gradually enters into this particular perforated pipes and then is drained away. But the design or the density of pipes or at what frequency we should give these pipes all depends on the pipe diameter as well as on the amount of leachate that is being generated. So we can also use construction and demolition waste, and above this we also have non-woven geotextile above the drainage layer so that it allows passage of water inside, and we can use construction and demolition waste to also instead of gravels we can use the C&D waste as the drainage layer as well. So HDPE pipes, polyethylene pipes are also used for leachate collection and for conveying the leachate to the leachate sump. As I was showing you in that image, we create a sump where the leachate gets stored, and from there we will pump it. Pipes with adequate flow capacity and structural resistance. Why structural resistance? So that it can withstand the load above, right? Load of garbage above. And collection pipes are perforated, and perforation size should be such that it prevents entry of gravel, but it allows adequate flow of leachate. So this is how a leachate collection layer looks. You can see over here, this is the HDPE membrane. This is the clay soil, and as you can see, the base is created, the mineral layer, sealing layer, liner, or the clay layer is first laid, and then we are laying the pipes. Of course, we put some sand, and then over that we lay the pipes, and we have to weld the pipes together, and these pipes are perforated, and above the pipes we cover it with the drainage layer like this, right? So this is how a landfill construction is going on. This is how this it is covered with this synthetic liners and so on. So before we even start construction, we have to create some test fields. That means this is again the process of construction of a landfill. So these test fields are created with the designs that we propose for the liners and the drainage layer and so on, so that we can see that how it performs in the local area, right? Because every area is different, weather is different, the soil conditions are different, so we have to test it. So we check the sanctity of the liner system. We can drive trucks on this particular test field, determine its density, how much it is deformed, Proctor density, that means how much moisture and how much it can be compacted, water permeability, moisture content, effect of compacted equipment, all these things could be evaluated in this test field, and finally we come with a final design. Accordingly, we create the liners. Then comes, we have talked about liners, which is at the bottom, but we also give sort of liners at the top, which we also known as cover, right? So we will call them as covers. So cover material could be either soil and other inert waste. It could be C&D waste, street sweeping waste, or dry drain cleaning silt. This could be used as the top cover material. It is applied through a bulldozer by pushing it, or a wheel loader by spreading it out as evenly on that particular waste surface. Side slopes are also covered. So this is how the overall cover looks like. So cover is done in many stages. As we discussed earlier, that at the end, at each cell is done, we put a soil cover, right? 10 centimeter. Now once a group of cells are done, and then we move on to maybe another area. So that means we have to, in that case, provide an intermediate cover. Why? Because this area is left unattended. Precipitation may happen and water may get inside. So we need to, instead of just a 10 cm cover, we know that we are giving 10 cm because the next day again we will work on it, we will give another 10 cm. So in that way it will go on, right? But if I am leaving a space, this area alone, that means more or less this work is temporarily done in this particular area. So it is not being actively filled within the next 180 days. In that case, we cover it with an intermediate cover, which is a little bit more. So that means around 30 centimeter thickness of soil is given on that particular area. So this reduces surface water drainage, infiltration, of course. But again, if this layer is, again I am now starting the second layer of operations overhead. So in that case, we have to remove this layer first, intermediate cover, and then we have to again do the cells above it. Why? Because if I keep this particular 30 centimeter layer, it may prevent moisture to go down. We want the moisture to go down from the top of the waste. Once it enters into the landfill, we will allow it to go down even so that it reaches the drainage layer. So if I provide an intermediate cover, that is temporary. So I have to remove the intermediate cover and then allow water to get inside, right? So that it will allow water to get inside. Now the top cover is the one at the top. So we will give this top cover so that we prevent water to get inside in the first place, right? But once it gets inside, we should allow it to flow through. So during monsoon, the intermediate cover of 45 centimeter soil or waterproof cover material is given. So that means normally it is a 30 centimeter, but for monsoon or where places of heavy rainfall, we can even increase it to 45 centimeter. So temporary surface covers are also given when the final height is reached before the final cover. So again, the final height we have achieved in some locations, other locations we have not. So temporarily some cover could be given so that it will allow traffic movement as well as prevents infiltration. So this is how the final cover looks like. It is also known as the surface sealing system. So we have waste at this layer, then we have a gas collection layer. Again, it is made of some of gravel. Then there is a separator layer. Separator layer could be geosynthetic, textile with some amount of amended soil inside it, sandwiched, right? Then there is a burial layer, which is again made of clay. So this is also called the top liner also, if you want to. Then there is a protector layer. Again, it could be protector layer of some sort of geotextile or some sort of membrane is given, right? So it prevents water to get inside. Above there is a sand layer which allows drainage of water. Then there is again a separator layer, and at the top of it is the vegetation layer. Vegetation layer allows plants to grow, right? So at the top we allow plants to grow. Why? Because it will prevent erosion. That means the plant roots will hold on the soil and it will prevent erosion, because continuously rainfall happens over it. It will flow over this particular soil, so it will erode, right? So the plants actually prevent that. But because we are putting plants and trees and so on, and water gets inside this particular soil, because this soil is not that clayey soil. So that's why we are given a sandy layer so that it allows water to accumulate and then pass out. Below it, we give this top cover, or the entire thing is the top cover, but here you can see this is the top liner, and this is where we put this clay soil so that water doesn't penetrate. but still, of course, some water will get inside. And then we have the gas collection layer, and finally there is waste, and below that again, after different cells, we will have the drainage layer as well as the bottom liner. So the gas drainage layer is 30 centimeter thick granular layer to facilitate gas collection, this one, and contains crushed gravel or crushed demolition waste, construction and demolition waste. The mineral clay layer is this one, 60 centimeter thick clay or amended soil, and if sometimes we use a HDPE layer over 60 centimeter of soil if in case it is very highly permeable. And HDPE liner should be covered with a 20 centimeter protection layer or geotextile, so that there is a protection at both at the bottom as well as the top. As I told, that whenever we have two separate material in two layers, to protect one from another, we can give this geotextile layer, which allows water to pass through but will prevent mixing, right? And then the water drainage layer is above it, 30 centimeter thick layer of crushed gravel covered by geotextile or drainage mat to prevent clogging of the drainage layer, and finally vegetative soil layer of 45 centimeter thick layer supporting vegetation at the top. So these are some other images, these are some other designs, you can take a look. So this is one design, this is another design, this is another design. So we can have different designs of top layer. It depends on what varieties of cover we give. Over here you can see that a topsoil layer is given, which is around 0.5 feet, and then 2 feet of barrier layer with 60 MIL of thicker flexible liner, HDPE liner substituted for soil barrier layer. So we use some amount of soil and some amount of HDPE layer, and so this is a very, very simple cover. This is a little bit complicated as we have discussed, and this one is even further complicated. This is another design, right? So each layer is different. We have to give a slope, of course, so that we allow water to flow down. We don't allow water to stagnate on this particular layer, and in this image you can see this is being constructed. So again, HDPE layer this is the top layer, top liner that is being given, HDPE layer is given, and above that we fill it up with soil, and this is the vegetation layer over which eventually trees will grow. So these are some of the references you can use. To conclude, area calculation for landfill requires detailed understanding of landfill operations and construction, and liners and covers are essential for preventing the exit of potentially harmful pollutants from the landfill. Thank you.